The presentation, Build Like the Future Depends on It, Beyond Foam High Performance Building Enclosures. A little bit about myself. My name's Erika. I'm the Eastern Canada product consultant for 475 High Performance Building Supply. I've got a background in architecture. I was the first employee of the Canada Green Building Council, and for many years had my own green building consulting firm. Our company was started by an architect and a building science consultant out in Brooklyn, New York. They were doing a lot of passive house, brownstone retrofits, and were really frustrated with the lack of product availability for high performance building products that they knew existed in Europe and other places and had been used for years and years very successfully in the high performance world. So they basically look to fill that gap in the market by distributing and importing those products here to North America. I think the difference with our company is that it's an e-commerce company, and as much as we provide products, we also provide a lot of great knowledge resources, and you can find that on our website at 475.ca in Canada. And that includes blog posts and videos and how-tos to really try to shorten the learning curve for people that want to build better. A big part of that is our resources and our ebooks that include lots of different construction types and detailing for how to do that and how to do that foam free, which is a big philosophy of our company, which we'll talk a little bit about later on in the presentation. So what is high performance? I think it's fairly, can be fairly subjective, but, we're talking about providing comfortable, healthy, energy efficient, resilient, affordable, beautiful buildings and homes. And I think, everyone puts different priority on a different aspect of this, but I think it's important to kind of address and outline that, high performance can mean different things to different people. But these are just some of the words that we use to describe high performance building. Today in this presentation, we're going to be focusing on a robust enclosure and building envelope. Other aspects like daylighting and toxicity of materials and indoor air quality and those kinds of things are other topics that we could also talk about. But I think for, when we talk about the building enclosure and trying to go foam free, we're really gonna just focus on that. We don't have a lot of time today, so let's get going. So just to address the why foam free, and I think, I always like to acknowledge that we've done a lot of high performance buildings with the use of foam, and that for a long time was really the only way that we could get really high R values and performance out of our enclosures, and that was a big step for a lot of people. I think what we're seeing now, and one of the reasons or several of the reasons why, philosophically here at 475 we're trying to reduce the amount of foams is, the toxicity of the materials and the need for people to wear hazmat suits to install it. It is shown to be an unacceptable fire accelerant and maybe not something that we want to put in our living spaces. There's a high level of embodied carbon, which we won't get into a lot in this presentation, but I think we will touch on it. And then just even if we're looking at from a performance perspective, we start to see, in that bottom right image, you can start to see maybe some shrinkage. And so all of a sudden this material that's been touted as providing, a continuous air barrier and vapor control and insulation all in one, as soon as you start to get some movement in your structure or shrinkage of that material, all of a sudden some of those elements become less reliable. And from a performance perspective, that can be concerning, especially as we go through this. We're going to talk about that air and vapor control aspect of the envelope. So for all those reasons, we like to try to say, we say less is best. From an embodied, just to touch on that embodied carbon perspective, this slide is actually from the Architecture 2030 materials palette. You can just see the amount of carbon that goes into different insulating materials. And so at the top of the spectrum, you've got your high density spray foam. And obviously when we go down to things like straw bale and hempcrete and more natural materials, we start to actually see that these are carbon storing. I think the other reason we want to move away from foam is that there are options now. And whereas maybe previously there were fewer, now we're starting to see a broader range of materials available that can achieve all of the performance goals that we have for our high performance buildings. So when we talk about a high performance building enclosure, these are the 4 elements that we like to focus on, and in the order of importance, which I think comes to a bit of, as a bit of a surprise to some people. The first one is really essential to all shelter, and it's really water control. We're not going to spend a lot of time on it. It's really about shedding that water and keeping water out of your enclosure. I think we can all agree that that's the number one goal of shelter in general. Where it gets a little bit, maybe where there's some differing opinions on this, is that we like to prioritize air control, and we'll talk about why that is in a minute, followed by vapor control, and then lastly looking at thermal control and what that means, and how we can get thermal bridge free envelopes. So starting with water, shed it. We want it to drain off our buildings. We want it to drain away from our buildings. And we want to do that because if you don't, it will destroy your building. And, even an abandoned building, that brick is not susceptible or not at risk of deteriorating, other than the fact that this particular image has a downspout running down the surface of the brick. And you can see where the water has not been shed away, it really can have a detrimental effect. So before you start looking at air control and vapor control and your insulation, really keep the water out. Air control can be a little bit trickier. Partly we can't see it. And so understanding what the impact of controlling it is can maybe be a little bit trickier. Some of the reasons we want to control that air and that air leakage is to improve the indoor air quality, talk about comfort issues, and I'm sure most of us have been in apartments that are super drafty or older buildings that are drafty. It has a detrimental effect on the comfort of building occupants. Air transported wetting, we know that air can bring in significantly more amounts of humidity into that space than if those leaks are not there. And then the more maybe obvious one is really that heat loss and energy efficiency. So when we start to talk about making more energy efficient designs, stopping the air leakage can really have a big impact. So what does that mean, air control? We want to optimize the insulation. So if you've got air moving through that insulation, you can see a whole bunch of examples at the top where, it's swirling around, or it's passing through, or it's moving. All of those things can affect how that insulation is going to perform. And so by surrounding the insulation with airtightness, you basically are keeping that air in the insulation still, and you're ensuring that that insulation, that R value that you spent all that money to add insulation to, is actually going to perform at the value that you intended it to. And I always tell the story of putting the wool sweater on when you're cold and you go outside, and you can kind of, yeah, you're warmer, but you feel that air moving through it. So what do? You go inside and you put a windbreaker on, and you haven't increased the amount of that insulation, but you've stopped the air from moving through it. And so you feel warmer, and you are warmer. And so it allows that wool sweater to keep you warm. Whereas just adding another layer that air can move through would not necessarily be as effective. And so this is the same thing for your building envelope, is that focus on stopping the air from moving through your enclosure to increase that performance before you start looking at increasing the amount of insulation. We like to prioritize a primary indoor air barrier and then a secondary outboard wind tight layer. And we'll talk about, what that could look like. So inboard, we may be looking, 475 sells a smart vapor retarder that can double as your interior air barrier. So you're getting your air control layer and your vapor control layer in one on the inside of the space. And you can see in the top, it's also protected with the horizontal wood there, so that you don't have additional penetrations through that, which essentially will add air leakage through the assembly. On the outside, the secondary air barrier, we're looking for it to be vapor open, and we'll talk about vapor control in a minute. This is doubling as your weather resistant barrier. So many of you are familiar with, say, a Tyvek. This is looking at using an airtight version of that weather protective barrier to provide that wind tight layer. And so with these two membranes, you're actually, if detailed properly and installed well, providing air tightness on both sides of the insulation. The biggest challenge, and especially when we're talking about renovations, is to make sure that that air barrier on both the inside and the outside are continuous. That can be tricky. So at penetration, so where your pipes are going through, if you've got structure going into your structural, how are you creating that continuous air tightness? And there's lots of different ways to do that. In a new build, you're going to want to think about the detailing and the sequencing of construction, which you can work with your contractor on. It's not rocket science, but it just takes some planning and some pre-thought. The nice thing about air control is that we can test it. And so you can do a blower door test to see how leaky your assembly is. And so this is a way also for you to check the quality of the installation of things like your membranes, your vapor and air control layers. Is the blower door test will tell you where you've got air leaks and gives you an opportunity to fix it, especially if you do it before your drywall goes on or your finished surfaces, gives you an opportunity to block those leaks and minimize risk in your assembly. So once we get that building airtight, now we want to pay attention to how the vapor is being controlled, and that's humidity moving through that assembly. So when we talk about smart vapor control, we're all familiar with sort of the leaky building, energy inefficient types of structures, and we can see that in the image at the top. Poorly insulated buildings, they basically are so leaky they heat themselves dry. So, if you've got brick or masonry, there's enough air and heat moving through those that, yes, they're very uncomfortable, but they also are removing moisture from that assembly. And so as we build tighter and tighter assemblies and add more and more insulation, we've got to think a little bit more about drying through vapor diffusion. And, we operate in a situation, we operate thinking that stuff does happen. So make sure that you're building a moisture tolerant design. There's lots of ways that that assembly can get wet. So saying it's never gonna happen can be, risky, because we know that things like building when it's raining and materials being wet when it gets enclosed in the wall can be a huge liability. So how can we build that assembly to dry out and increase what we call the drying reserves? So just a little refresher on how moisture moves, especially in our climate when we've got, colder, drier winters and then hot, humid summers. So in the wintertime, we've got sort of, like I said, colder and drier air on the outside of the assembly. And inside we're heating this space, and so it's more humid. We've got people breathing and living, and so we've got warm, humid air that wants to move towards the exterior. And so this is why in a lot of our buildings we see that 6mm poly. It's to act as a vapor barrier to stop in the wintertime humidity from going into that assembly. And so what we want to do is we want to continue to minimize the potential for the wall to get wet from that air on the inside. The challenge for us in our climate is that in the summertime, that vapor drive changes. And now all of a sudden, especially as we increase the amount of air conditioning we're introducing into our spaces, is that we've got cold, dry air on the inside and hot, humid air on the outside. And so what does that mean? It means that warm, humid air wants to move from the outside to the inside. And so, do we really want a vapor retarding material on that interior surface? Or do we want something that's going to allow and facilitate the assembly to dry in the summer months? So what do we do to, make sure that we can dry outwards? And we're looking at what we call vapor open. So membranes and materials that allow vapor to go through while still being airtight. Here we see the Proclima's Mento 1000 on the roof and on the walls. We see minimal structural panels that can kind of block. The use of vapor open sheathing at the exterior. So exterior grade drywall that allows some moisture to go through. On the bottom right, we see wood fiber insulation board, which is very vapor open. Or no sheathing at all. So starting again to minimize the amount of those panel products that can sometimes be quite vapor closed, and just really making sure that if there is moisture, that it has a way to get out. Because we know that at some point, again, with that, starting with the assumption that it will get wet at some point, making sure that there's a way for it to dry. At roofs and walls, looking at having back vented rain screens. So, that's where you're putting strapping and a way for not just rain, if it gets through your siding material, a way for it to get out, but really a way for air to pass and carry away some of that humidity before it goes into the wall. So looking at doing that on the walls and at the roofs, again, to facilitate drying on the outside. We also want to make sure that we're not damming moisture around openings at the exterior. So whereas traditionally we're taping all around the corners and providing really vapor damming, now we've got technology that has, vapor open tapes. So you can put those at the perimeter and that humidity can start to dry to the exterior if it gets in there. We know that penetrations tend to be the most, susceptible to moisture as well. On the interior, we're looking at, what kind of vapor control materials can we use? And we see a whole variety of them. And I just wanted to give a bit of an overview on what sort of options we see. So, OSB, if people are using that as their air and vapor control layer, we're looking at a perm rating of between 0.5 and 2 perms. So fairly vapor closed. And this can vary depending on the manufacturer as well. Plywood has a little bit more ability to handle moisture if it gets wet, up to 10 perms. There are a lot of vapor variable membranes available on the market, and we're seeing, again, a range of 0.8 to 5.5 perms. So again, a little bit, from fairly closed, anything below 1 is considered fairly closed, to 5.5 perms. And then Proclima has a smart vapor control, smart vapor retarder. And this is completely airtight, but has a vapor variability between 0.13, so very, very closed, all the way up to 13.2. We'll talk a little bit about how that works. But first of all, the reason you want that is, again, because of that change in seasons. So in the summer, when you've got a low relative humidity at that membrane, the perm rating is going to be in that 0.13, so very vapor closed, and will act as a vapor barrier. In the summer, when you've got warm, humid air coming from the outside moving to the inside, that humidity level at the membrane potentially could be quite high. And we see in the bottom corner, we'll look at this again on the next slide as well. Once that humidity level starts to get around that 70% relative humidity, then that perm rating, and that's the yellow line you see going straight up, opens up to a perm rating of 13. So again, it's allowing that assembly to dry. And the chart on the right shows you sort of over time the differences with different materials. So OSB or equivalent, a polyethylene sheet is the red line, your vapor variable membranes, and then at the bottom you can see the smart membrane. And what you can see is that over time, as we start talking about, not just 6 months from now, but 10 years from now, continuous drying of that assembly because of its ability to dry in both seasons. So Intello Plus or Intello X, regardless, has that same vapor curve. And the vapor curve is referring to that chart at the top. So it's at what point will the smart vapor retarder actually be vapor open compared to when will it be vapor closed. If we look at the exterior and your weather resistant membranes, the technology has changed a lot as well. So old technology talks about a microporous membrane. So this is sort of how Gore-Tex works. The holes in the fabric are very, very tiny, that they won't let bulk water through or rain, but they are still there to let kind of the humidity and let that material breathe. Tyvek works in this way, as do most other weather resistant barriers. If we look at technology that's available now, is that we're looking at monolithic membranes and a TEEE layer, which is completely waterproof. And what happens is it moves that moisture through an active vapor transport along that molecular chain. And don't ask me to start quoting PhD research here, but essentially what it allows is it allows those molecules to move through the chain, and as opposed to moving through a hole in the fabric. That's why all the Proclima weather resistant barriers can also be used as roof underlayment, because they have a high ability to hold large water columns and be waterproof, but vapor open. This is just a good example where we had a project that had used both like a Tyvek microporous membrane, which you can see on the top, and a Proclima Mento membrane. And at one point they thought they had a leak in the roof, but really this was just the pores in the Tyvek layer got overwhelmed with moisture at one point, and so it started to condense and was no longer vapor open as originally intended, versus the Mento, which stayed completely dry. And I think it just goes to show, like, these membranes and some of the new technology will allow that performance in all conditions for the lifetime of the building. And the same goes with tapes, is just, as much as we've got vapor open tapes, we also have durable molecular bonding. And this means that it's not just glue attached to a paper facing. This is going to bond at the molecular level with your substrate, and so will provide long time durability and adhesion, so that, again, if we're looking to have 100-year buildings with consistent performance, these are the kinds of things that we need to pay attention to. So again, I'm sure we've all seen, different caulkings and sealants that have been used, and yeah, over time they shrink, they crack, there's movement. We want to have adhesion that isn't compromised in different weather conditions and isn't compromised over time. And finally, just a quick look at thermal control, and what, when we talk about doing thermal bridge free, I think the diagram on the bottom left is a really good example. So we see this, typical construction where we've got our exterior wall and then we've got a partition wall that's butted right up against it. And you can see in the thermal diagram that this is a particularly susceptible place for there to be the transfer of cold and hot between the exterior and the interior of the building. And this can cause all sorts of issues, from just, cold surface temperatures to condensation in the assembly and the like. In the middle one, we've kind of wrapped that insulation into the space a little bit, and you can see what that does is that reduces the thermal bridge and sort of spreads out the transfer between that exterior wall and the interior wall. But even better is to separate those partition walls and have continuous insulation, either on the exterior or on the interior, but really creating that separation so that you minimize and reduce the transfer of the heat. So again, think of it as a thermos. You want to kind of envelop what you're protecting with insulation, and not having ways for hot or cold to leave. And from a moisture perspective, when you're looking at insulation, you want to, again, facilitate that drying. We've gone to all the trouble to have vapor open exteriors and vented rain screens and vapor barriers that can open and close with different humidity levels. We want to make sure that we're putting in insulations that are also vapor open, and things like cellulose, which you see on the left, or wood fiber insulation or wool insulation. These are all insulation types that can handle moisture and handle the movement of moisture to help facilitate drying. Again, when we talk about foam products, this is another area that if we operate under the scenario that assembly will get wet, foam's great because it doesn't let water in, but if that water does get in, it also means it can't get out. And so thinking about insulation as a system with the rest of your assembly is really important. So just to summarize, make those layers continuous. So think about airtightness and vapor control in a continuous manner, and think about the details connecting all the parts of your building. Try to minimize the use of plastic foams, again, for that overall durability and health of the building. Always blower door your buildings. This is your quality assurance from an airtightness perspective. It gives you assurance that the work was done the way you intended it to be done. And protect your control layers with those sacrificial finishes. So again, when you're looking at those airtight layers, try to protect it so that, every time somebody goes to hang a photo, they're not puncturing, your continuous airtight layer that you went to such lengths to protect. And that's all I have for you today. So build like the future depends on it, and thank you very much.